Okay, let's implement our algorithm for finding strongly connected components as shown in this pseudocode. So this is the pseudocode that we are going to follow. Now let's see the implementation. Now here in this strongly connected components function, I have mainly done three things. First, I have called topologically sort function, which I have already described in the previous videos. And then I call getTranspose function to get the transpose of original graph. And finally, I have called DFS on that transpose graph by taking the vertices in topologically sorted order. Now let's see each of these functions in detail. I have already discussed with you about topological sort, therefore I am going to skip that part. Now let's see how to get the transpose of a graph. Now in this getTranspose function, our target is to construct new vector called graph transpose list, which represents the transpose of the original graph. Now notice that in the original graph, we have stored the pointers to our vertices in our graph. Hence, we have to make sure that the original vertex list in our graph remain unchanged in this process of finding transpose. Hence, I have first populated our transpose list with new vertex object which have same IDs and values as our original list. Now we have to find adjacency list for each of those new objects in a way that it represents the transpose of the graph. For that, I have traversed through all the edges in our original list and add those edges in reverse order to our transpose list. Now these for loops in line 110 and 113 represent the traverse through all the edges. Now inside this for loop, I have another for loop which is going to iterate through transpose list and find the particular vertex with same ID and add particular connection to the adjacency list in a reverse order. Now after finding transpose, and then I have taken the vertices from the process list or the list which contains the vertices in topologically order, and then find the corresponding vertex in the transpose list and then call DFS on vertex in that transpose list. So this is the implementation of our strongly connected component. Now let's see how this function works with an example. And in the main function, I have reconstructed the graph which we have discussed in the previous video by adding nodes and necessary edges. And then I have called a strongly connected component for this graph. Now let's run and see what is the outcome. Okay, now as you can see in a separate line, it will print out each strongly connected component in that graph. Now if you look at the components that we find in our previous discussion, you will find that these are same as those components. So that's how we can implement strongly connected components. So that's it for this video. See you in the next video. Thank you.